Right, so we're on to network protocols part 3, hopefully the last part. I feel like we are done with them. So I'm going to start with a recap because there is a lot of knowledge in the protocols section of this topic. So as we've talked about a lot, you have got this 2-mark definition of a network protocol, which is a set of rules governing how data transmission takes place across a network. And there's different rules for different activities. So if it's anything to do with web browsers, it is the HTTP protocol. If it's anything to do with emails, it'll be one of these 3. If it's anything to do with transmitting data across the internet, it'll be to do with TCP/IP. Okay, so different rules for different activities. Now that's an important concept to keep at the forefront of your mind whilst we talk about layering. Okay, so layering takes it a step further again. So we're looking at how we break things up. So as far as networks are concerned, a layer is a group of protocols which have similar functions. So if we have a look, on layer 4, all these protocols are based on user interaction. So we interact with the web browser. We will upload or download a file. We will send an email. Okay. We don't, however, as a user interact with TCP. We don't see the packets being split up and labelled. We don't see the data being directed from one router to another. We don't see the data travelling down an Ethernet or a fibre optic cable. So they have grouped them by kind of similar functions. Now, in terms of how they work, each layer is self-contained. Now what that means is HTTP will only ever be found on layer 4. TCP will only be found on layer 3. Okay, that kind of thing. Everything within that layer is only on that layer. And each layer serves the layer above it. So, say we make a request for a website. We want to load up BBC Bitesize. We use the web browser and the HTTP protocol will be used. Okay, now that then serves the next layer, layer 3, where all the packet stuff's done. That layer serves layer 2, and so on and so on. And the last thing, you can only pass data from one layer to the one that's next to it. So you could never pass data from layer 4 to layer 1. It has to go through this process. And equally at the other end, it has to work its way back through. Okay. So why do we bother? Okay, it felt like there was a load of new information here. Why do we then complicate things further by putting our protocols into specific layers? Let's have a little look. Firstly, it breaks the network up into more manageable chunks. So say you're the creator of Ethernet cables, you've got a factory creating Ethernet cables, you only have to worry about the protocols on layer 1. Okay, so if we go back, you don't care about what's happening on layer 4 or layer 3. You are dealing with Ethernet cables. You only need to worry about layer 1. You can make a change to one layer without affecting the others. So if we take, for example, the conversion from IPv4 to IPv6 addresses, that will only be happening on layer 2. Any protocols on layer 4 don't care about the new versions of IPVs. Okay. And lastly, is to try and make common standards. So making sure that companies are creating hardware or software that work in the same way. Okay. What did I want to say about? Oh, in terms of that first point, if you are a developer of web browsers, then you would only be concerned with the protocols on layer 4. So it's this idea of breaking things down into manageable chunks. Please watch this through a few times. Layers is a little bit of a topic and it's quite abstract, but it's the kind of marks that you want to make sure you are ticking those boxes on. So watch the video again. Make sure you're confident with what layers are, where you would find the protocols, and why we use them.